Hello my dear students and viewers, welcome back to my YouTube channel. My dear students, in this video I am going to give you the running notes of the chapter acid, bases and salt. You know very well it is a class 10 science second chapter. Now let's move on to the running notes, and here it is acid, bases and salt. Depending upon the chemical properties, all compounds can be classified into number 1 acids, number 2 bases, number 3 salts. Now what are acids? Acids are chemical agents released hydrogen ions when added in water. See what are acids means? One definition, one single point I have given. Basically acids are of two types, organic acids and mineral acids. Organic acids we also called as natural acids. Now natural acids, acids which occurs naturally and are edible. Examples to that natural acids: citric acid which is present in lemon, tartaric acid which is present in tamarind, and now next oxalic acid which is present in tomato. Okay, and next folic acid which is present in green leafy vegetables. For the point of examination you have to focus on this. For 1 mark question may arise like which acid is present in lemon, which organic acid is present in tamarind. Okay, now let's move on to the second one is mineral acids. Mineral acids means acids which are prepared in lab, which are non-edible. You know, they are used for experimental sake, and examples to that acids are number 1 sulfuric acid. It is a king of the acid which we are called as H2SO4. Hydrochloric acid, nitric acid, acetic acid. Okay, so H2SO4, HCl, HNO3, CH3COH. These are the examples for mineral acids. Now let's move on to the next one. There are two types of mineral acids. One is concentrated acid and one more is dilute acid. Concentrated and dilute. Okay, now properties of acids. There are 4 points are there here. Acids are sour in taste. Okay, now next one is acids are liquid in state. Acid changes blue litmus to red litmus. This is important point. Acids are highly corrosive. Okay, these 4 are the properties of acids. Now such like only move on to bases. A base is a substance. A base is a substance that can accept hydrogen ion and releases hydroxide ion. Okay, so bases means in bases OH minus ions are common. Okay, OH minus ions, hydroxide ions are common. Examples to bases are sodium hydroxide, magnesium hydroxide, calcium hydroxide, ammonium hydroxide, potassium hydroxide. And here you see the molecular formula: NaOH, MgOH twice, CaOH twice. All the compounds have end with OH. Okay, which compounds end with OH we basically called as bases, and here certain exemptions are also there, so that we don't want here now. Now let's move on to the properties of bases. Bases are bitter in taste. Bases are bitter in taste. Bitter means nothing but so kahi. Got it? Now bases are liquid and few are solids. Thereafter bases are soapy in nature. Bases are soapy in nature, or it may oily in nature. Bases change red litmus to blue litmus. Okay, red to, it is nothing but red to blue, red to blue. Okay, bases end with OH, which means hydroxide. Bases which dissolves in water are called alkalis. This is also important definition. What are alkalis? And here you have to write bases which dissolves in water are called as alkalis. Okay, now such like only let's move on to salts. All chemical powdered compounds found in labs are called as salts. So later one more definition you will get here. There are two types of salts. One is amorphous salt, and one more is crystalline salt. Amorphous salt means nothing but powder form, and crystalline form means nothing but crystals. Okay, now here many examples are there. You need to remember salts are end with Cl, it means chloride, and carbonate, bicarbonate. Okay, so sulfate. Got it? See here examples are there: sodium chloride, NaCl, sodium carbonate, Na2CO3, it is nothing but washing soda, sodium bicarbonate, calcium oxychloride, bleaching powder, and calcium sulfate, CaSO4, which we are called as gypsum. Regarding its preparation also we are going to discuss in this chapter. Next, properties of salts. Salts are salty and sweet in taste. Salty and sweet in taste. Salts are solid in taste. Salts are crystals or amorphous in nature. These are the properties. All salts are transparent or colorless. Most of the salts are soluble in nature. Salts basically end with chloride, carbonate, or it may sulfate, or it may bicarbonate. These are the properties. Now let's move on to indicators. Definition to indicator. Basically indicator is a dye. It is a dye or chemical substances which gives different color when dipped in acid or bases. So this is we called as definition. Got it? And now such like only there are two types of indicators. One is natural indicator and second one is synthetic indicator. This is also important question. What are indicators? Like that question will arise. If not means in the base of examples of natural indicators and synthetic indicators, you may able to get the question in upcoming examination. See examples to natural indicators. One is litmus paper and second one is litmus solution, turmeric, red cabbage, okay, flower petals. Okay, these are the natural indicators. And now synthetic indicators, basically two indicators are there. One is phenolphthalein indicator, another one is methyl orange. Synthetic indicators made by using chemical substances which we used in laboratory. Got it? And now which among the following is natural indicator and synthetic indicator? Such like question will come. And the next one is olfactory indicators. One more most important concept. This is most important. Many a time question have arisen in the annual examination. What are olfactory indicators? Give example. There are some certain substances, okay, some substances whose odor changes. Odor means nothing but smell in acidic or basic media. Okay, there are called as olfactory indicators. Easiest to have definition. And now example, onion extract, vanilla extract, clove extract. So here one word you need to be add, that is nothing but extract. Okay, extract means it's juice, extract formed one. Okay, neutralization reaction. This is also one of the most important concept. Neutralization reaction. When acids react with base to give its respective salt and water. This is we called as definition. Okay. Now examples to that: acid plus base gives to salt plus water, and acid HCl, hydrochloric acid plus sodium hydroxide. When hydrochloric acid and sodium hydroxide mixed and 2 drops of phenolphthalein indicator if we have added, then we will get sodium chloride and H2O. Okay. So such like only, let's move on to the next one. What do common in acids and bases? In acids, hydronium ions are common. What do common in acids and bases? Hydronium ions are common. In bases, hydroxide ions are common. In acids, hydronium ions are common. In bases, hydroxide ions are common. Okay. And now let's move on to the further. Acid solution in water conducts electricity. Pure water is a poor conductor of electricity. First point. Now the second point, if you add 2 to 3 drops of acid in it, then it becomes acidified and conduct the electricity. Okay. So this is the diagram. Now I hope you have practiced well, and now for that explanation is there, just you copy it as it is. How do acids ionized or dissociate? Dissociate means nothing but break down into ions. Okay, when what happens to an acid or a base in water solution? Acid in water. Okay, so acid in water always produce hydrogen ions, but hydrogen ions cannot exist alone. Okay, so just you go through it, and now this will be even we can say how does the formation of hydronium ions takes place? That like question will come. Hydronium ion formation. Hydronium ion formation. Okay. Now thereafter most important one more question, that is dilution of an acid. While diluting an acid, why it is recommended that the acid should be added to water, not water to acids? 2 points are there. Most important question. Dilution of concentrated acid in water is highly exothermic. This point you must write. If water is added into concentrated acid, heat produced is too large that the solution may splash out of the beaker due to excess of heat. Okay, so most important question, go through as it is. Simple 2 points I have made. Bases in water. So what happens when bases, if you add in water, it produces hydroxide ions. Now next one is water alkalis, already we have discussed, and the examples also. Next one is universal indicators, acid base indicators. Definition is there, universal indicators. And one more most important concept, that is nothing but pH scale. And this pH scale, that is very important. Okay, so I hope you have understood well this one. Here pH, P means potence, okay, power, hydrogen, okay, H for hydrogen. If pH range is less than 7, then it is considered as acid. Okay, more than 7 it is considered as neutral. Sorry, equal to 7 neutral, more than 7 base. Now importance of pH in everyday life, I have made easiest 2 points, just you go through it. pH in our digestive system, our stomach produces hydrochloric acid, that is gastric juice, whose pH range is 1.2. This is also important. HCl pH range is 1.2. It helps in the digestion of food. Excess of HCl in the stomach causes indigestion. This concept also you have to be, for when indigestion happens, that time to control it we have to use antacids. Okay, now examples, milk of magnesia, that is nothing but MgOH twice, milk of magnesia, or it may lemon and soda, or it may we can use Eno also. Okay, now antacids are basic in nature. What are antacids? What are antacids? What are its uses, like question may get, and these 3 points are important. Now antacids react with excess of acid in the stomach and neutralize it. These 4 points also you need to be remember, dear students, so you may able to get the question in upcoming examination. pH changes as the cause of tooth decay. Now the second one is pH changes as cause of tooth decay, reasons for tooth decay, and mouth less than, pH of mouth less than is 5.5, pH range you remember. Tooth enamel made up of calcium hydroxyapatite. Okay, it is a crystalline form of calcium phosphate. Clear? And now the next one, how tooth decay causes, regarding that point is there. Bacteria present in the mouth produces acid by degradation of sugar, and food particles remains in the mouth after eating food. So how does tooth decay causes? Like question arises means this point and this first point you need to write, and such like only for preventive measure is there. Okay, to prevent the tooth decay, then what else we have to do? Tooth decay can be prevented by using bases like toothpaste. Toothpaste is a base. Toothpaste neutralize the excess of acid and prevent tooth decay. Okay, so all important points I have given. Now the next third one is plants and animals are sensitive with pH range. Now here first point is our body works within the pH range of 7 to 7.8. When pH of rainwater is less than 5.6, it causes acid rain. When acid rain flows into the river, it lowers the pH of river water and survival of aquatic life becomes difficult. And there are chances are there to ask here applicative level of question. Easily we can able to. Next, let's move on to soil pH and plant growth. The pH of fertile soil is 6.7. Okay, 6 to 7. If the soil is too acidic, then it is treated with materials like bases, quick lime, okay, chalk powder, slacked lime. Here also in your textual question, one applicative level of question is there. Applicative level of question. So these 2 points we can able to write. Now let's move on to the further. Here one more point is there. You be remember for that first. Now next one is self-defense by animals and plants. First point and second point you just as it is go through it. And here nettle leaves and ant bite inject methanoic acid. Okay, this methanoic acid, or it may also called as formic acid. Okay, so this question also arised for 1 mark many a time. Now let's move on to strong acid and strong base. As it is, you just to go through it, and differences also I have given. Copy it in your notebook, such like only strong bases and weak bases. The next one more important definition, before last year it has arisen in the annual examination. What is that? Water of crystallization is a fixed number of water molecules present in one formula unit of salt. Example for that is Na2CO3 dot 10H2O, that is sodium carbonate decahydrate. One example you write. What is water of crystallization? Give example. Name the gases which liberate under chlor-alkali process. So just go through it. This one in salts concept you will again. So uses of hydrogen gas as it is points are there. Now the preparation of plaster of Paris and as well as the gypsum regarding is the easiest way. Just go through it. Now next uses of plaster of Paris, 4 points I have given, just go through it. And such like only preparation of gypsum, just opposite of POP, just to go through it. And thereafter in this chapter salts concepts are there, my dear students. See, N1 is NaOA, NaCl, and here the uses are there. Just you zoom yourself, pause the video and try to copy. Preparation is also there, and here uses also there. Washing soda and its common name, molecular formula, everything is there. Common salt, its molecular name is sodium chloride, and chemical formula is NaCl. Na2CO3.10H2O, it is nothing but washing soda. Sodium carbonate, its preparation and uses, and such like only. Caustic soda, its uses, 4 uses I have given. In that any 2 to 3 uses you just practice for the sake of examination. So for whatever we have noticed the chlor-alkali process that comes in this is most important one. Sodium hydroxide, its common name is caustic soda. Okay, and now preparation of this one by chlor-alkali process. Okay, so here uses also there. And regarding chlor-alkali process also, output liberated gases uses also given, just to go through it. Thereafter baking soda is there, just on the base of uses you go through it. Molecular formula, chemical formula, molecular name as well as common name, you just have it in mind. So again and again you write and practice, and moreover you will get certain activities here. Okay, so 7 activities will come. Number 1, acids react on metals. So you know, dilute sulfuric acid or dilute sulfuric acid reacted with zinc granule. This will be very important diagram for the sake of examination. It will be carries 3 marks, so practice very well. And such like only for its explanation I have given. Now final equation you just have it in mind. The output gas is nothing but hydrogen gas. And how do you test that hydrogen gas? Regarding question will come here. Bubbles are formed to find out what kind of gas is passed. Bring burning sprinkler nearer to the bubble. If it produces pop sound, then the released gas is hydrogen. Pop sound concept you need to be remember. Okay, so just one point you remember for the sake of examination, and which gases are liberated, that you remember. And second one, bases reacts on metal. Diagram is not much important, just output gas you remember. Here also hydrogen gas. When bases react with metals, see here whatever point I have given, just you go through it. Now the next third activity. So what it is, acid and bases reacts with each other, that is we called as titration reaction. Okay, and now titration reaction is a type of neutralization reaction, just go through it. Now the next one, acids reacts on carbonate, that time which output gas will releases, that is carbon dioxide. And equations are most important here. These equations you practice in two different test tubes, what and all the changes happens, that also you need to be. It turns milky calcium hydroxide into milky white color, that all concepts I have given, just 2 points also you go through it. And the next one, acids reacts on bicarbonate, regarding that also is there. And here equations you practice well, dear students, for the sake of examination. And last concept, that is nothing but metallic oxides react with oxides. Metallic oxides react with acids it is. Okay, so here a small correction you have to be, that is nothing, this is not oxide, this is acid. Okay, and now this is the output reaction takes place. Now the next one, non-metallic oxides react with bases is there. Now that this one you practice well. Okay, this equation is important. If limited supply of carbon dioxide, it gives calcium carbonate. Excessive supply of carbon dioxide gives calcium bicarbonate. That concept all it comes. This is about the chapter acid, bases and salt. Right now these points you just go through it in upcoming videos. The most important and higher order thinking questions, each and everything I will upload in my YouTube channel. Okay, so thank you very much, dear students.